Now that we've taken a look at uncompensated, we're going to take a look at partially compensated. The good thing about partially compensated is it looks almost exactly like the initial state. So if we're talking about respiratory acidosis, then the pH is still down. That hasn't changed. And guess what? The CO2 is still up. The compensation is now coming from the kidneys because now instead of this being a normal value, in order to compensate for this acidotic state, you're going to notice that you have an elevated HCO3 level. It makes sense when we know that this is a bicarbonate and we know that this will help buffer this acidosis. So when we look at respiratory alkalosis, again, our pH is still up, our CO2 is still down, but now in order to buffer or compensate for the fact that this person is too alkaline, we're going to notice that this HCO3 level decreases because you don't need as much of this substance in your body because you're already alkaline. When we look at metabolic acidosis, again, this is not going to change. It's still a low pH. When we look at our HCO3, again, it is also low. But now, because we're trying to compensate CO2 with the lungs compensating, if we're already acidotic, we're going to notice that that CO2 level decreases because we don't need as much CO2 in the body to mix with water to make that carbonic acid. When we look at metabolic alkalosis, we're going to notice that, again, that pH is still increased. We're going to look at our HCO3 is still increased. But now we're going to see the lungs try and compensate by having us retain more CO2 so that we can compensate for the fact that we're already in an alkaline state. The body can retain more CO2 to mix with water to make carbonic acid to compensate for this pH.